look at one more of these problems. I believe this is number 18. Get my pen activated here. Okay. Alright, so we have the parabola, which is 10 minus x squared, meaning it's up here, y-intercept of 10, opening downward. Okay, we have a rectangle that's being built within this. So let's suppose that this is a rectangle here. Alright. We've looked at these on Sketchpad. Sorry about that. Whereas we've designated this point on the curve as xy. Our curve, of course, is y equals 10 minus x squared. Okay? And based on this point, we can obviously say that this is x and this height is y. Alright, now what it is that we're trying to do, express the area of the rectangle. Okay, so of course, area of a rectangle is base times height. Now, okay, in our case though, the height we certainly can call y, but I think we'll need to call the base 2x. Okay, so the area will be 2x times the height, which is y, but of course the height now is 10 minus x squared, so we now have the area is equal to 2x times 10 minus x squared. Alright, so the area as a function of x is negative 2x cubed, okay, plus 20x. Okay, that's the area as a function of x. And while I'm at it, I think I'm going to optimize this just to show you again how we do this with the calculator. So we'll be back and do that optimization in just a minute. Okay, we're back. Now, I'm going to put on my calculator the y in y equals. Okay, my function as we defined it there, negative 2x cubed plus 20x. Okay, I instructed my calculator to graph it, and we're going to presume that this problem is going to be asking for the maximum area confined here. So you can see that the screen is not permitting us to see that. So I'm going to look in this area here, which should be running from 0 to right here, radical 10. The x-intercept should be radical 10. So that's 3 point something. Okay, so what we do is, again, we will bring up our calculator. We will turn on our table set, and we will go auto, starting at 0, maybe in increments of 0.25, let's just say. Okay, and when we look at our table now, go back and look at our table, we're going to try to see where this is peaking out. So for the x values as stated here, A is still increasing, and it seemed to increase up there to about 24, where it started trailing off. So somewhere in this range of x value of 1.75 to 2, we've got we're peaking out. So what we got to do is we got to go to diamond F2 to set up our window. We're only interested in x values which are positive, and like we said, the cutoff is going to be over here at that intercept, which is, you know, roughly 3 or 4, we'll go up to 4. And we saw our y values are jumping up to a high of about 24. I'll give ourselves some breathing room, go up to 30, okay? All right, that said, we can graph that, and within this box here, we'll find our high point, okay? Again, this is not quadratic, as you could see. It is non-quadratic. The graph does not peak out midway between the intercepts, which it would do for quadratic, and therefore negative b over 2a is not going to apply. So we're going to F5. We're going to find our maximum, okay, and our maximum, we're going to scroll to the left, enter, scroll it over a little bit to the right, enter, and it's going to determine for us that that max value is 1825 with a maximum area of 24.34. So had we wanted to find the dimensions that maximize this, it would be the base here would have to be 2x, so that would have to be twice 1.825, and the height would be y, which would be 10 minus, okay, the x value of 1.825 squared, okay? So they would give us the dimensions of this box of greatest area. What we did here in total, you should be able to do for any problem listed, okay? I know that the problems are only asking for you to write the function, but I will ask you to optimize the problem via your calculator for test problems, okay? So you do need to know how to do that. There you have it.